Okay, so good morning, everyone, or good day, everyone, if you're watching this in the afternoon. So, last week we met and discussed the class policies as well as a short introduction to what discrete mathematics is. Today, our topic is the foundations, logic, and proofs. Okay, so before we proceed to discussing the logic and statements or propositions, we are going to have a short review about what discrete mathematics is. Okay, so what is discrete mathematics? So from the word discrete mathematics itself, so we refer to the part of mathematics that is devoted to the study of discrete objects. And these are the kind of problems that may be solved using discrete math. So for instance, we want to compute for the ways there are to choose a valid password on a computer system. So consider this example from this site. So it computes for the time it takes a hacker to brute force your password in 2022. So as you increase the number of characters and as you increase the variation in the password, like the numbers only, including a lowercase character, including both the uppercase and lowercase characters, using numbers, upper and lowercase characters, and lastly, including symbols, the more difficult it is for a hacker to figure out your password. Okay. So another example or a problem that may be applied with using discrete math is computing for the shortest path between two cities using a transportation system. Suppose you are in this area and you want to go to this area. So are you going to take this path? Are you going to take this path, this path, this path, etc.? Okay, and this is a problem that has already been applied in the industry, like the Uber or Grab or Google Maps. And not only that, it is based on the distance, but they are also using the traffic information. Okay, so for example, if there's an event in this area, then it's most likely that there is a traffic, then you have to avoid that path. Okay, so even if this path is longer, but if there's no traffic, then still that may be considered as the shortest path and the shortest time that you can get into your destination. Okay, and in order for you to solve problems like this, you need to learn the discrete structures and techniques. Okay, and you will be learning that in this class. Right, so more generally, discrete math is used when, as we have mentioned earlier, it is a branch of math. It is a mathematics that is devoted to studying discrete objects. But what is a discrete object? When we say discrete, we refer to something that is distinct or separated. In other words, the objects are countable. So, and it's also, discrete math is also used when we deal with finite or countable sets. So consider this example. So we have here a Venn diagram of a finite set as well as an infinite set. An example of an infinite set is a set of whole numbers. So when we talk about the word infinite, meaning from the start to the end, the values may be endless. Okay, so and in between, within a certain range, there are infinite numbers that may be included. Okay, meanwhile, for the finite set, the finite is there is an end, or the elements may be counted. So for instance, this finite set only includes 3, 8, and 13. And we know that there are only 3 numbers included in this set. So we can consider this as a finite or countable set. Okay, going back, when we say discrete math, discrete data means that it can only take certain values. And these are some of the few examples. The number of students in a class. You cannot have half a student, right? So we can say that we are 3.5 students in a class. So that is not correct, okay? Because there is no such thing as a half student. So another example is the results of rolling 2 dice. So these are the possible list of the possible outcomes. So when you roll 2 dice, so you could have 1 and 1, but you cannot not have 1 and 0 um, because a certain dice can only take values 1, 2, 3, 4, 5, and 6. Okay, right. And meanwhile, the continuous data can take any value within a range. So some of the examples that we have discussed last time is the weight. So for instance, you have eaten a cookie, right? So your weight before and after eating a cookie will have a different will have a difference no matter how small it is. Okay, so you cannot categorize a certain height na okay, or okay, ikaw, this group is only 5 feet tall. I mean 50 kilograms only. So there is no such thing. So no matter how small, there will be differences. So another example of a continuous data is the height. So a person's height could be any value within the range of human heights and not just certain fixed heights. So another example is the time in a race. So you could even measure it in a fraction of a second. And last example that we have is the infinite decimal places of pi. Okay, so in here we are just showing the first 100 decimal places. So it is infinite. You cannot, the value is not discrete. Okay, now through learning discrete science through this course, what you can develop is mathematical maturity. And what we mean by mathematical maturity is your ability to create and understand mathematical arguments and your ability to solve certain problems. Okay, and in order for us to understand the mathematics, we must understand what makes up a correct mathematical argument. Okay, so what is indeed a correct mathematical argument? So the rules of logic specify the meaning of mathematical statements or mathematical arguments. So logic is the basis of all mathematical reasoning and all of automated reasoning. So, and it has plenty of applications or practical applications to the design of computing machines, to the specification of systems, and now for the hype, which is the artificial intelligence. And now you're also learning computer programming, and logic is very important in computer programming other areas as well as other areas of knowledge. Okay, so in order for us to understand mathematics, so we must understand what a correct mathematical argument is. That is a proof. So once we prove a certain mathematical statement, we call it a theorem, right? Okay, so and as if we want to be good at math or if you want to learn a certain topic, so we need to actively construct mathematical arguments. Okay, so going back, so these rules of logic, so these rules are again give precise meaning to mathematical statements. And these rules are used to distinguish between a valid and an invalid mathematical argument. Okay, and as I have mentioned earlier, proof is what? Proof is what makes up a correct mathematical argument. Okay, so besides the importance of logic in understanding mathematical reasoning, logic has, again, numerous applications to computer science. So these rules are used to design computer circuits. And these rules are used to construct programs, correct the programs, and also to verify the correctness of a certain program. But and in many other ways. Okay. So our goal here in this lecture is to understand and construct mathematical arguments. So we will begin our study with an introduction to logic. Okay.